Hello, and welcome to the latest installment of the Aras Innovator Demo Series. Today we're going to discuss dynamic 3D product navigation. The demo series runs for 30 minutes and features all demo with no sales pitch. Each installment showcases a different capability of the Aras platform. During the webinar, everyone is on global mute. If you have any questions, please submit them in the questions panel within GoToWebinar, and we'll answer as many as possible in our Q&A session at the end. This demo is being recorded, and when the recording is available, you'll receive an email with the link so you can share with your colleagues or review it again for reference. We have on the line today Kevin Richard, Director of Product Execution at Aras. Kevin, take it away.
Thank you, Nicole, and welcome everybody. Today I'm going to talk about 3D visualization. And before I go into the demo, I would like to just provide a brief overview of a fairly extensive initiative that we started here at Aras earlier this year to enhance our 3D visualization capabilities. We've had 3D visualization in our product for quite some time, and our goal has been and will continue to be to provide a simple, intuitive user interface for our users to visualize their 3D product without the need for any server or client-side plugins or any additional software. Going forward, we are going to transition or provide additional functionality to what is now a single part or single static assembly visualization tool, something that we refer to as dynamic product navigation. And I'll explain a little bit more what that means in the next slide. Our goal is to be able to extend 3D visualization to other areas of our product and to other PLM processes like detailed design, technical documentation, manufacturing process planning, eventually MRO, and others as well. In order to do that, we know that we need to provide an environment or a framework that allows for a certain level of content definition and view definition. So allowing our end users to control what shows up in the 3D view as well as how it's rendered. We're also working on capability for spatial analysis, 3D search, looking for all parts or instances of parts that either touch or are in the vicinity of a selected instance of some component within their data model, including interference check. Finally, with this extensive visualization capability, we know that this functionality, these 3D views, will come in handy if you want to use that for technical illustrations. Okay, so let's talk briefly about what dynamic product navigation is. So there are essentially two components. If we refer to the diagram on the right, I have a view here of a compartment. It's got a series of piping, and I've got some pumps here in the foreground. The dynamic portion of this refers to the ability to control through some custom logic or conditional logic through queries what shows up in this scene. In addition, we have an area on the left to show related information that you have within your PLM system. The second component is navigation. So when I'm looking at a 3D view, for example, I may not know what this pump is, what its model number is, or its name, or anything about it. And I may not care, but what I may want is to get information related to it. So when I click on it, I want to be able to show related information that we have stored in the PLM system. Okay, so those are the two components why we call this dynamic product navigation. So what is our strategy? So I mentioned that we started this initiative earlier this year, and we knew we needed a certain level of capability or a minimal viable product MVP. And that included support for what is typically called a shattered data model, the ability to compose 3D elements dynamically. And we needed a certain level of configurability, and we will continue to expand on these features as we move forward. So this is a multi-phased effort, the first of which will be released with our 12.0 SP2 later this month. Going forward, we want to incorporate other product engineering features like effectivity and eventually variance when it's released. We want to be able to implement solutions for larger data sets, improve performance, both server side and client side. We want to be able to incorporate graphics and other 3D visualization to other Innovator applications. And finally, integrate spatial analysis. That's the interference checking, proximity search, things of that nature. So that's our overall strategy. So let's get into the demo. And I have here a version 12 SP2 instance. Again, this will be released shortly. If you haven't seen the 12.0 release, you'll notice right away that the interface is quite different than what we had in previous releases of Innovator. Here I've got a part search displayed, and I'm going to open an assembly. And this is our typical MakerBot assembly that I'm going to show here that we use quite extensively in demonstrations. So here we have the form view, and depending on the related content, you have various tabs of information, which are now stored in these various accordion user interface widgets. So if you've used 3D visualization in the past, you know that we have 3D visualization tool. It's accessed via this icon on the sidebar. And this capability provides, again, I mentioned earlier, we're trying to provide a fairly intuitive, easy to use interface. We have some functions for cross-section, for explode, for measurement. You can control how this content is rendered. And on the left, you'll see what we refer to as a model browser. These are links to all the various CAD items that are associated with different components within this view. If I select something over there, it's selected in the 3D view and vice versa. Okay, so there is a synchronization between what's happening in the 3D view portion and the model browser. In SP2, if you load the dynamic visualization capability, there'll be an additional icon on the sidebar here. And when I select it, I am bringing up a different version of our viewer. So it has similar functions up top here. You'll notice it has cross-section and explode. There's some measurement capabilities as well. But if you notice what's happening here on the left, this is a different view of what we refer to as a model browser in our static viewer here. However, everything that happens in this view to render this scene is completely different than what was used in the static viewer. Okay, so you'll notice it's a similar view, it's the same assembly, but everything that is rendered in this view is done so dynamically. And I'll explain a little bit more when I refer to the data model in just a bit. On the left here is a tree grid view. And if you've seen any previous webinars on Query Builder and tree grid view, this is capability that we launched quite a while ago in 11 release. And query definitions and tree grid views are based on a defined query. We refer to it as a query definition. And the execution of that query definition controls what shows up here on this display. All right, so it provides a fairly extensive amount of capability for what we include, and within the tree grid view definition, how it's rendered. Okay, so just like the monolithic view, we've got the ability to select elements in this tree grid view display here, and the corresponding geometry highlights on the right. Likewise, if I select something in the 3D view here, the corresponding element shows up in the tree grid view. Part of what's different, and this is fairly extensive, is our ability to control what renders here. Eventually, we'll have additional controls over how this content is rendered. But let's focus on the tree grid view. What happens is, I mentioned this is a dynamic display, okay? So what shows up in this scene is the product of the execution of some query. And to explain that, I want to bring up a separate view here. And I just want to provide an overview of our basic CAD structure data model. When 3D content is loaded into Innovator, it's loaded most of the time through a CAD connector. These are plugins to all the major CAD systems that allow you to connect to and add or retrieve or update CAD information within Innovator. And when that happens, there's a particular data model, CAD, the BOM hierarchy is determined by CAD structure, and so on and so forth. And all of this is built automatically for you when you interact with Innovator through the CAD connector. So let's go over here to query definitions. Again, we've had other webinars that show how to use query definitions. Let me just open this default one here. And if you notice the description, it says default query definition for the dynamic viewer, do not remove. We need to heed that note, but let me just expand here so you can show you the elements that make up a default query. All the elements in this query definition are needed in order to render a 3D view. So we have CAD, CAD structure, CAD instances, which determine the instances and the transformation. And again, all this is generated automatically through the check-in process and corresponding conversion process that happens when users check in 3D geometry with Innovator. So if you look at this diagram on the right, you see sort of a graphic image of this assembly, and then you have all the components and sub-assemblies that make up this assembly that are stored in related CAD data through CAD structure. In our static viewer, if I go back here and if I were to open up this view, okay, what I'm really looking at is a static view of this assembly. When I transition to the dynamic viewer, all the various components are queried and assembled dynamically, okay? So let's go ahead and generate an alternative view. And in order to do that, what I need to do, I have to go back over here, query definitions. And if I right click on this element and say save as, I'm basically creating a copy of that default query definition that I can then go and add or modify in certain ways. All right, so I'm going to open that. And when I open a query definition, I am opening it in, you can see the form. I'm just going to go ahead and lock this and change its name. Let's call it, I'm going to call it part information. Okay, still the same query. I'm just going to rename it. And let's get rid of this so it's not confusing. I typically recommend that when we generate or users generate query definitions that there is a description added so that it's clear what the purpose of this particular query definition is. So let's go over here into what we refer to as our query builder. This is a graphical user interface that allows us to essentially construct queries, but what we're really doing is building a structured data model. And it's this structured data model that we use to map to various views. Tree grids are just one type of view. Graph navigation is another view. And in 3D, that's yet another way of using or visualizing the elements that exist within a particular query definition. Okay, so I copy the query definition, and here, these are all the base elements. So what I want to do, I'm going to come back over here, my data model here, and I want to add additional information that I want to show up on the left side of the dynamic viewer. Okay, I want to configure additional information here, and I also want to control how these individual CAD elements are displayed. And in order to do that, we have to have an understanding of what the data model is. So I explained the CAD and CAD structured data model. If I want to get information about its related parts, I do that through the part-CAD relationship. And you notice through these arrows here that parts refer to CAD elements as opposed to the other way around. So parts point to CAD, if you will. And from part, I can get additional information as well, like related documentation. In this case, parts point to documents. Okay, so in order for me to include this information in the tree grid view, I need to add these elements into my query definition. And I do that through this query builder user interface. So I'm going to start here with CAD. Okay, if I right click, you can see add related item. And because I want to bring in something that is referencing CAD, I do that using a referencing item. And when I select that, I'm given a list of all the items that have item properties that point to CAD. And I'm interested in part CAD, so I'm going to select that and click add. When I do that, I've got a row added to my query definition display here. However, that just gives me part CAD. I haven't gotten the CAD yet. So in order to get that, I then need to add a related item to bring in the corresponding part, which is the source ID. So if you're familiar with Aras Innovator, you know that everything is an item type. We hear that over and over. And there are basically items and relationships. Relationships have pointers to the related and to the source. And that's why I had to bring in part through the source property. I also mentioned that in this case, I want to bring in documents. So I start with part, I click on it, and I want to add a related item. In this case, using a relationship. So I'm from part looking down into document. So when I select that, I know that that relationship is named documents. If I select that, and you notice I have this checkbox include related here set. And when I add that, I have both the part document relationship and the corresponding document item. So these are the elements that I want to add to the tree grid view. And the only thing I've done so far is just identify the elements. I haven't identified what property information I want to add in. So in order to do that, what I use the interface to identify, select individual properties that I want to include in this query definition. And I'm going to add a few properties to CAD. I'm going to add some properties to part, and I'm going to add some properties to document. Before I do that, I want to make one other adjustment. Based on this data model, I could have multiple generations of parts pointing to CAD, but in this instance, I only want the latest one. It's just my choice, but that's how I want to set up this demo. In order to do that, if I come over to this toolbar on the left here, you'll see if I hover over this filter icon and I select it, I have the ability to modify the conditional logic of how parts are selected. Okay, that's the where condition. So if I say is current equals to 1, I'm only going to get the latest version of that part when this query is executed. So I'm going to save that. You'll notice that where conditions show up on the right of the query items. So where conditions here, join conditions are over here, what links these two things. And I can go ahead and shut these off and make it a little cleaner, but I like to leave them on because it gives me a better understanding of how I'm structuring this query. All right, so I added that condition, and I want to go up to CAD here. And because we copied the default query definition, I'm going to go, it doesn't have all the properties that I want. So I'm going to go in here. If I select this, I have the property editor. This is my user interface for adding content. And I'm going to add some properties. So if I click on add property, I have all the properties that are associated with this particular item type and only this item type. And I can go through here and select the ones I want. For this particular demo, I'm going to select the released flag. I'm going to select the revision. I'm going to select the released date. And I'm going to select the name. Okay, so I'm adding 4 properties to the CAD query item here, and I need to save in order for that to take place, for those to be set. Likewise, I want to add some properties to part. And it's the same scenario. In this case, I'm going to add the ID. I'm going to add the generation. And I'm going to add the name. I will save that. And finally, I want to add some properties to document. In this case, I'm going to add the ID. I'm going to add whether it's released. I'm going to add the revision. I'm going to add the released date. Now, if you have any modifications to the data model, of course, those properties would show up as well. And you can choose what it is that you want to include when this query is executed. I'm going to save that. So here I've constructed a modified query I've added part, as I talked about. I've added document. I've added the properties, and I modified some of the conditional logic. If I had more time, I would show you other ways of adjusting conditional logic to filter different parts. But I think this is sufficient for now. So I created a query definition, and structure-wise, it matches what I have here on the right. Okay, so I've got a query definition. I have data, but I don't have my view defined. In this case, I need to create a tree grid view for that, because it's the tree grid view that is the visual component of that. So I'm going to go in my tree grid view, and I'm going to create a new one. So when you generate a tree grid view, you have to identify the corresponding query definition. That is the data. If you're familiar with software engineering topics of model, view, and control, the query definition is the model. The tree grid view is the view and the control. All right, so part information is what I just created. I'll say okay. Let's give this a name. I'll call it something similar, part information, and I will save that. When I save it, you see that the context item type is CAD. That's driven directly from the query definition that I selected. All right, I go over here. This is how I define my tree grid view. And in order for elements to show up in the tree grid view, they need to be mapped. So I'm going to go ahead and select individual items here. I'm going to select the part, map that, and I'm going to map the document. So I want CAD items, I want part items, and I want document items to show up in the view. Okay, so I can add a single column, keep the single column, or I can add additional columns. And before I do that, I want to identify what data do I want to show up in this display. So if I double click on this cell, rather than key name, which is the default, I want to choose a CAD name. So if I choose CAD name and I double click on it, I have the CAD property that shows up on the left. I want this displayed as text, so I will save that. And you notice that these are automatically defined in the view here. For part, I want to do something different. I want to add name, and all I'm doing is double clicking here, but I want to add some additional information. So I just hit the space tab. I'm going to have a left bracket, and in that bracket, I want the generation. So if you remember, I added a condition that should only show me the latest generation of that particular part, and I get that from the Boolean is current. All right, so I had the part name, space, bracket, part generation, and an end bracket. I'm going to save that. Likewise, for document, I want to add the document name. In other words, I want to see the document name when I visualize this in Innovator. And I know we're running short on time, so I'll just do real quick. I'm going to add a column, and I'm going to say released date. All right, so I want to include the release date here. If you remember, I added that information. Did I? Oh, maybe I didn't get it for CAD, so yeah, I won't do it there. But here I did. Release date. And when I display the release date, I want to display it as a date. Okay, so rather than text, I wanted this to display as a date. Okay, so I won't make any other changes here, but I just wanted to show you that you can modify how things show up and you can add additional columns. So I'm going to go ahead and save that. In order for this to be deployed for a 3D visualization, I have to go back out to Tree Grid View and right click on this one and say set usage for 3D visualization. I'll do that. And you'll notice I get an indication here that it was assigned successfully. Okay, so now if I go back into part and I refresh, I'm going to reload this element. And when I do that, you'll notice that when I hover over this 3D visualizer, instead of one, I have two. So if I click on it, I have a choice between the default or this new tree grid view that I just selected. So I'm going to go ahead and select that. Bringing up the 3D view, I didn't change any of the conditional logic for the CAD data. So it's the same components that are going to be queried and rendered. But if you notice here in the tree grid view, instead of the key name, I'm getting the name of the part. And if I expand and just bring this out a little bit, you'll see that I have my added column, and if I expand each of these, you can see the related part and if there is any documents. And I think we are out of time. I want to spend a little bit of time on questions if they exist.
All right, thank you, Kevin. Make sure to enter in any questions you have into the questions panel. We have a few submitted questions, so let's get into some of those now. Is the CAD data translated using the hoops publish to 3D PDF?
So we translate CAD data using Hoops Exchange, and we do that through Hoops Communicator. Exchange is the conversion software that we use. And with Exchange, we also have the ability to convert to 3D PDF. So yes, we do use, it does use publish capability under the covers, but we do so using Hoops Communicator.
Is conversion server needed with this new capability?
The conversion server, yes. The conversion server capability has been modified, and it's been modified so that we can generate, if I go back to my data view here, these CAD instances are what gives us the instances and the transformations in order for us to position these in 3D space. And that is generated automatically as part of an updated conversion process.
What file formats are viewable in the viewer?
Right now, it is a hoops file format. It's referred to as SCS or Streamcast Single. That is a viewing format that hoops uses specifically. But if you're familiar with our conversion capability, we can generate JT or STEP or PRC. We can also convert from a number of different native CAD formats.
Okay, we're almost at time, so I'm only going to take 2 more questions here. Can I use parameters with the query definition?
Not in this release, but in SP3 you will be able to. And in fact, parameterization gives you much more flexibility to filter content in the 3D view, and it will also provide the capability to use structure resolution. So being able to pull in the latest part in a BOM hierarchy.
And our last question for today, are any changes to the CAD connectors required for this capability?
No. The conversion logic has been updated, and through that capability, we extract all the necessary transformation and instance data. We store that in the CAD structure data model, so it's there for the visualizer to use.
All right. Thank you, everyone, for your questions. For the ones that we didn't answer, they will be addressed directly within the next few days. I'm going to leave you with our upcoming demo series topics. On October 10th, we will see a demonstration of Aras Innovator connecting simulation to the digital thread. Then on October 24th, we will hear more on managing commercial parts with component engineering. You can register for upcoming demos and view any past demos at aras.com/demo series. We'd love for you to join the Aras community at community.aras.com. There you'll find blogs, community projects, and forums, all with a lot of great information. Be sure to connect with Aras on LinkedIn, Twitter, and Facebook, where we share the latest updates and news, product information, and more. Finally, don't miss ACE Europe this November. We'd love to see you there to answer your questions, get your feedback, and take the opportunity to network with the PLM community, the Aras team, our partners, and more. We thank you for joining us today and look forward to you visit us next time. Thank you and have a good day.